Let's have more practice on this equilibrium condition. Suppose there's a chain. It's in a slack position as shown, and suppose it is symmetric. This angle theta and this angle theta are the same, and it is suspended from two ends. The weight of the chain is suppose W. Then it has been asked that what is the tension in the chain at the end position, these two end positions, what is the tension? So to find the tension at the end position, we must draw the FPD of the chain. Suppose this is the end position and this is the tension from both the ends. This is the FPD and mg is acting downward. So the weight has been given. So mg is equal to W. W is acting downward and these two chains are acting in this direction. This angle has been given as theta. So now it's very easy. The tension at both the terminal has to be the same, because from the horizontal equation of equilibrium you can see if this is T1 and this is T2, T1 cos theta will be same as T2 cos theta for horizontal equilibrium condition. So T1 has to be equal to T2. Now writing the vertical equilibrium condition, we have T sin theta, 2T sin theta is equal to W. T from here we get W cosec theta by 2. Okay. Now I hope you are solving along with me. Let us solve this one. Okay, so in this problem, I'm giving you 4 options and you have to choose one which is correct. So what is your answer? Your answer should be A, because A is the correct option. And solving it is pretty easy, and if you have already got along with this kind of problem, then you can skip the discussion and move on to the next problem, or else you can join the discussion. This T and this T will be the same, and let us call this as T dash. The reason why these two T will be the same, because if you look at the horizontal equilibrium condition at this knot, then there are only these two forces only will have the horizontal component, because this is vertically downward. So, and the angle are the same. So T1, if we call this as T1, T1 cos 45 has to be equal to, if we are calling this T2, T2 cos 45. So from there we get T1 and T2 are the same. So this should be very clear to you that this tension and this tension would be the same. Now if you write the horizontal equilibrium condition for this capital M, suppose this is T dash, then from here we get T dash cos theta is equal to, this is 45 degree, T cos 45 degree, or T by root 2. And if you write the vertical condition for vertical equilibrium, this is T dash sin theta is equal to The other vertical force would be the vertical component of this tension, which will be downward, away from the body tension, right? Downward. That would be T sine 45 degree, and plus the mass of this ball, which will be capital mg. So from here we get that T dash sine theta is equal to T upon root 2 plus capital mg. If you write the equilibrium condition for this in the vertical direction, we'll get 2t cos 45 degree is equal to small mg. This gives us T is equal to small mg upon root 2. So if we put T is equal to small mg upon root 2 in these two equations, we get T dash sine theta is equal to small mg upon 2 plus capital mg, and from here we'll get T dash cos theta is equal to small mg upon 2. If you divide the first equation by the second, you get tan theta is equal to 1 plus capital 2 times capital M upon small m. So that was option number 1, I guess, option number A. So this is the right option. Okay, so you can see in each and every problem we are doing the same thing over and over again. What we are doing is we are writing the equation of equilibrium in horizontal and vertical direction. That's it. That's what we are doing. So it is very basic maths what we are dealing with. Yes.